Hi everyone. All right, so part B of the penny activity. What you were asked to do was to drag the red points to fit the curve. So you can try to do that as best as you can. So when I drag it, I'm going to try to fit the data so it represents it as best as possible. So I'm going to try to see something maybe like that. And let's go ahead and see what happens next. All right, so based on the way I moved my red, the points, it gave me an equation for this model. And you can see that this equation is clearly quadratic. It has a square on the variable. So the equation in my case is 1.36 x squared. So depending how you dragged your model, your equation would look a little bit different. So what would change would be the coefficient, which is your a value, in this case 1.36. All right, so then it goes on to say that my original just right estimate was 350 pennies. And then it says, based on everything you know, now make a final calculation. So because I'm giving an equation, I can make a calculation using my equation. So it says how many pennies fit into the 22-inch circle. So I'm going to just go ahead and type in the equation in the box here. Y equals 1.36, and I'm going to enter 22, and if I square 22, you can see it's already calculating for me on the right. So for 22, it would give me 658 pennies, 0.24. Now, obviously, there is no 0.24, so this is an estimate. All right, and here we go. It does make sense. If you can see right here, it does make sense that my calculation, that I use the calculator to enter X value, it will fit on my curve. Now my estimate is right here. It shows me how far off I was. What is the diameter of the smallest circle that would enclose 2,000 pennies? Recall your model's equation. All right, so for this slide, they're going backwards. They're saying what would be the diameter if you had 2,000 pennies? So our 2,000 pennies is actually our Y value. So in other words, we have 2,000 is equal to 1.36, and we want to know what diameter that would be. So that is what we're looking for. We're looking for X. So we, of course, can solve this algebraically. We can divide both sides by 1.36 and then take the square root. I'm going to see if there's a Desmos graph where I could show if I actually drew the equation y equals 2,000, that would be a flat line. Let's see if I could show that here using the calculator. All right, so here is the equation, and here's the line y equal to 2,000. Let me see if I could zoom out. So do you guys see how here's the equation of the parabola, here are the dots. Now we have zoomed out a lot. So when I draw the line y equals to 2,000, you could see that it intersects at this point right here, which is 38.2. So if you were actually to solve for your equation, you would get that the diameter would be approximately 38.2. Or if you wanted to say rounded, you would just say about 38. So this would be about 38.2. Okay, explain your thinking. So if you want to rephrase what I said before, so basically It's just an input output. If you had a table, you went backwards. When y is 2000, what would x would be? Solve for the equation, or as I showed you previously with the graph, where they intersect. All right, would you rather have all the pennies that fill a 40-inch diameter circle or all nickels that fill a 20-inch diameter circle? All right, so here it's easy to say, oh, well, I would rather use the nickels because nickels are worth more. But I would like you to elaborate a little bit more. So if you do say pennies, explain why it is you think pennies. If you say nickels, explain why you think nickels. So for example, nickels may be worth more, but they also take a lot more space, right? Pennies are a little larger than nickels. Sorry, let me rephrase that. Nickels are a little larger than pennies, so that would take up a little more space. So you could say something like that. And here it shows us what the actual final estimate is. Let me zoom it faster. So 663, and my final calculation was 658, so that was pretty close using the class data. Okay, what is the difference between tables, graphs, and equations? So something you could say with a table, you can easily see your observations. You can see your observations. With a graph, you can see the shape. And with equations, it's much easier to calculate. So that is a sample response you could give on the last slide. Okay.